Linux updates rarely make headlines outside the technology world, but every once in a while, a new kernel release quietly lays the foundation for changes that millions of people will eventually experience without even realizing it. That's exactly why Linux 7.2 has caught so much attention. At first glance, it may look like another routine update filled with bug fixes and driver improvements. But if you look beneath the surface, you'll find a release that continues shaping the future of Linux across desktops, servers, AI systems, cloud computing, gaming, and even decades-old hardware. The biggest changes aren't flashy, they're the kind that make Linux stronger for years to come. When people hear Linux update, many assume it's something only developers care about. In reality, the Linux kernel is the core of countless devices around the world. It powers supercomputers, cloud servers, Android smartphones, smart TVs, networking equipment, embedded systems, and an increasing number of desktop computers. Every improvement to the kernel has the potential to affect billions of devices, making even small updates far more significant than they appear. Linux 7.2 is currently moving through its release candidate stage, with the third release candidate, or RC3, continuing the testing process before the stable version is expected later this year. Release candidates aren't final releases. Instead, they allow developers and testers around the world to identify remaining issues before the kernel reaches millions of users. According to Linus Torvalds, this release cycle is progressing normally, with nothing particularly alarming showing up so far. One of the most interesting aspects of Linux 7.2 isn't one revolutionary feature. It's the sheer number of improvements happening simultaneously. Around half of the recent changes are focused on drivers, covering graphics hardware, networking devices, storage, and many other components. The remaining work includes updates to file systems, architecture support, core kernel functionality, documentation, and development tools. Instead of chasing flashy announcements, Linux developers continue refining thousands of small pieces that together create a faster and more reliable operating system. Graphics support remains one of the biggest priorities for modern Linux. Every new generation of GPUs introduces new technologies, and keeping Linux compatible requires continuous work. Driver improvements in Linux 7.2 help ensure better compatibility across different hardware configurations, including systems with multiple graphics cards. These improvements may not immediately appear dramatic to average users, but they reduce compatibility problems that previously caused crashes, display issues, or inconsistent performance. Networking is another major focus. As cloud computing, virtualization, and high-speed internet continue expanding, Linux must handle enormous amounts of network traffic efficiently. Every optimization to networking code can improve responsiveness, reduce latency, and make servers more capable of handling heavy workloads. Since Linux powers a significant portion of the world's internet infrastructure, even relatively small networking improvements can have enormous real-world impact. The file system changes included in Linux 7.2 also deserve attention. File systems determine how data is stored, accessed, and protected. Improvements in this area help increase reliability while reducing the chances of corruption and improving performance under demanding workloads. For businesses managing thousands of servers, these refinements can translate into greater stability and lower maintenance costs over time. One detail that surprised many enthusiasts involves support for older hardware. Linux has long been known for keeping aging devices useful long after commercial support disappears. Linux 7.2 continues that tradition by delivering fixes for the Sega Dreamcast's input drivers, improving support for keyboards, mice, and controllers connected through the console's Maple bus. It's remarkable that a gaming console released in the late 1990s is still receiving meaningful Linux improvements today. At the same time, Linux developers continue making difficult decisions about removing support for hardware that has effectively disappeared from real-world use. Legacy processor architectures that no longer receive meaningful usage are gradually being retired so developers can focus their efforts on modern hardware. This balance between preserving compatibility and reducing unnecessary maintenance helps Linux remain efficient while still supporting an enormous variety of devices. Artificial intelligence is quietly influencing Linux development as well. Linus Torvalds recently noted that AI-assisted patches are becoming part of the normal development process. That doesn't mean AI is writing the Linux kernel by itself. Instead, developers are increasingly using AI tools to assist with code generation, debugging, and reviewing changes. Human maintainers still review and approve every contribution. But AI is gradually becoming another productivity tool inside one of the world's largest software projects. Developers are also preparing Linux for the next generation of processors. Linux 7.2 continues improving support for RISC-V, the open instruction set architecture that many believe will play an increasingly important role in future computing. Expanding default support makes Linux more ready for upcoming hardware while encouraging broader adoption of open processor designs. Performance improvements remain another important reason why each kernel release matters. While benchmark numbers may only increase slightly in some situations, Linux gains efficiency through hundreds of tiny optimizations spread across scheduling, memory management, storage, networking, and device drivers. Individually, these improvements might seem insignificant, but together, they create an operating system that feels faster, smoother, and more responsive over time. Desktop users may also benefit even if they never manually install the kernel themselves. Popular Linux distributions such as Ubuntu, Fedora, Arch Linux, OpenSUSE, and others regularly incorporate newer kernels after sufficient testing. As those distributions update, users automatically receive better hardware support, improved stability, and stronger performance without needing to understand every technical detail happening underneath the desktop environment. Gamers also stand to gain from these ongoing improvements. Better GPU drivers, improved hardware compatibility, and continued work across graphics technologies contribute to smoother gaming experiences. Modern Linux gaming depends on a rapidly evolving software stack, and every kernel release helps strengthen the foundation supporting compatibility tools, game engines, and graphics drivers. The cloud industry pays especially close attention to kernel releases. Most of the world's largest cloud providers rely heavily on Linux. Better scheduling, networking, storage efficiency, and hardware compatibility directly influence operating costs across enormous data centers. When Linux becomes even slightly more efficient, those gains multiply across hundreds of thousands of servers operating around the clock. Security is another area where incremental improvements matter. Every release candidate includes fixes for bugs, regressions, and edge cases discovered by developers and testers worldwide. Many of these fixes never become public security incidents because they're resolved long before reaching stable releases. This constant process of testing, reviewing, and improving code is one of Linux's greatest strengths and helps maintain the reliability expected by enterprises and governments worldwide. One interesting observation from this release cycle is how calm it appears compared to some previous kernel releases. Linus Torvalds described the development process as looking normal, despite slightly higher commit rates than in the past. That may not sound exciting, but in kernel development, normal is often exactly what developers hope to see. Stable progress usually means fewer unexpected problems before the final release arrives. Perhaps the biggest reason Linux 7.2 matters isn't because of one headline feature. It's because it demonstrates how Linux continues evolving through thousands of carefully reviewed improvements instead of relying on dramatic redesigns. Every driver update, file system improvement, networking optimization, architecture enhancement, and bug fix contributes to an operating system trusted by billions of devices worldwide. The future of Linux has never depended on one spectacular update. Instead, it has been built through decades of continuous progress driven by thousands of contributors working together across the globe. Linux 7.2 follows that same philosophy. While many users may never notice these changes directly, they'll experience their effects through faster hardware support, improved stability, stronger compatibility, better gaming, more reliable cloud services, and an operating system that continues adapting to the future without sacrificing the reliability that made it successful in the first place. That's why Linux 7.2 isn't simply another kernel release. It's another important step in the quiet evolution of the operating system that powers much of the modern digital world.